Trigonometric ratios, special triangles. Well, this is the last question on my communication series, C10. And as you have seen, every question is with a purpose here, right? And this probably is the most important of all. The question says, prove that sine square A plus cos square A equals to 1, where A is an acute angle in a right triangle. Explain if this is true for any angle. Any angle A, right? It could be acute, obtuse, or anything, correct? So that's the next part. Now, if sine square A plus cos square equals to 1 for any angle, then this equation will be called an identity, because equations normally are true only for few values, while identities are true for all values, correct? And that's why it plays a very significant role. And you'll find use of sine square A plus cos square A equals to 1 in most of the trigonometric identities. Let's try to prove it. So let's first make a right triangle. So let me just draw one here for you. So there is one. So to make it a right triangle, what I will do is just make this thing here. So this indicates that that is a right triangle, right? We don't really have to measure the angles, correct? Now, angle A is the acute angle. So if this is 90 degrees, obviously the two other angles are acute angles. So any one of them can be called A. Well, let's take this as an angle A, this as angle B, and this as angle C. So if this is the angle A we are talking about, then what is sine? Sine should be opposite side over hypotenuse, correct? So let me write this side as small a. So normally what we do is that side opposite to the angle is normally written by a lowercase letter. So in that case, for me, this side will become B, right? And that side will become C. Look carefully. I have named my triangle ABC, not ABC the other way. And therefore, I'm landing up with sides which are A and C here and B there, okay? So be careful. Normally we say A square plus B square is C square, but in this triangle, since we have named it so, our small sides are A and C and the big side is B. The B is for big now, okay? Now, from Pythagorean theorem, I hope you remember, in a right triangle, what is true? Squares of these two sides, if you add them up, you get square of the third side, correct? So we get what? We get A square plus C square, okay, is equals to the big square B square, okay? That's how it is. So that is Pythagorean theorem. Now what happens if I divide everything by B square? So let me rewrite this for you. A square plus C square equals to B square, and now I'm dividing everything by B square. Okay, everything by B square, both sides, so that means the equation is maintained, right? So we get A over B whole square. Now A over B is what? Well, as you can see, A is also your opposite side, correct? So if you see a triangle, this becomes the opposite side, right? Let me write here opposite, OPP, right? And this is my adjacent, and that is my ADJ, and that is my hypotenuse. Is that okay? Now, when I say A over B, that means opposite over hypotenuse. Opposite over hypotenuse is what? In terms of trigonometric ratios. You get it. So A over B is actually sine A and square of sine A. Do you see that? So we get sine square A plus C over B. C is adjacent over hypotenuse. Adjacent over hypotenuse is cos. So we get cos square A, and B square divided by B square is 1. And that proves our identity. Do you see that? And this is one of the most important identities in trigonometry. And that opens a whole lot of things for us, correct? So that's one beauty. Now I will prove this sine square a plus cos square a equals to 1 in a different fashion. So that is, let me call this an alternate proof for the same thing. Now this time I will take a point on a coordinate system. So let's say that that's my point, and let me call this point as P, right? And the coordinates for P as usual will be X and Y. So it means what? It means that if I drop a perpendicular from here, then this side, this side from 0 to here should be of length X. This is my point X, correct? And if I join this, let me join it with the origin, right? Like this. Let me join this, correct. So now I have a triangle. Now this triangle should be a right angle triangle since I have made a perpendicular here. Is it okay? That's fine. And now when I say that point is xy, that means from here to here this distance is how much? That distance is y for us. Is that okay? Perfect. So we have x and y, and this, let this be called as hypotenuse, or let me call this as r, correct? Now using Pythagorean theorem, we know what is r. So r is equals to square root of x square plus y square, correct? Since x square plus y square equals to r square, we can simplify this as this. Well, if you remember, well, let me go back to it. We say x square plus y square equals to r square, right? Now I can square root, right? So if I square root, I get what? I get square root of x square plus y square is equals to r. That's what I wrote, correct? So that is my r, the hypotenuse. Now let us see what is sine square a and what is cos square a in this case. So if I write, let me start with sine square a plus cos square a. So I'll start with sine square a plus cos square a. Now what is sine square a? It means sine a square, right? What is sine a then? Sine a is opposite. Let's say this angle is a, okay? Now this angle is a for us. So sine a will be opposite over hypotenuse, which is r. So I can write this as y over r and whole square. Is it okay? Because it is sine square a. Now what is cos square a? Cos square a is adjacent over hypotenuse. Adjacent is x. So it is x over r whole square. Perfect. Now let's open this up and we say, what is this equal to? We'll see, okay, what is this equal to? So we get y square over r square plus x square over r square. Good. Now let's add them up. They have common denominator of r square. Let me write it down here. And the numerators add up, right? So we have y square plus x square. Now what is x square plus y square? Do you see that? X square plus y square is r square from the Pythagorean theorem. X square plus y square is r square. And therefore, instead of x square plus y square or y square plus x square, we can write this as r square in the numerator, and we have r. So we have r square over r square is equal to 1. Perfect. So we started with sine square a plus cos square a, and we found that this is equal to 1. So that is how we can prove that sine square a plus cos square a is equal to 1. So that is a proof, an alternate proof for the same thing. So now you are doubly sure that yes, sine square a plus cos square a is 1. Now what you can do is, you can make any triangle. That means I could have had a triangle rather than this side over here. Correct? In that case, that will become my triangle, right? And the angle A will be this angle. That will be my obtuse angle. But what is sine A? It is, again, let's say this point is let us say A comma B, right? Any general point, A comma B. In that case, this side will be A and that side will be B, correct? So A square plus B square remains PQ, which is R. Do you see that? So we will see that whether the triangle is acute or obtuse, we will get the same result, right? Because effectively, it is a right angle triangle, correct? So that is how we prove that sine square A plus cos square A equals to 1. Alternate way is also you can take many different values of A, any angle. For example, you can use calculator and take angle as 30 degrees, 40 degrees, 90 degrees, 100 degrees, 120, 30, 150, 250, 270, 280, 300, 360 degrees. And you can check with all these angles and you'll find that sine square A plus cos square A is 1. So that is the ultimate proof by taking different values of A, correct? So that's how it is. So remember, sine square A plus cos square A is always 1. Perfect. Thank you.